Okay, so hello, Maria. Maria is this girl with a white hat, and Dmitry Tsitov is a man with a white background. So you kind of think that you are similar, but you're not. So let me ask you some questions. So Maria is probably the new engineer, like you can see by their age, probably Dmitry is very awesome engineer, but he's fully experienced, and he started to work on Lincheck. How many years ago, Dmitry?
I believe it started about 7 or 10 years ago from the first student works inside Dix Lab in the experts.
Okay, and now everything is in for young blood, which is Maria. Maria, how long do you work?
I'm working at JetBrains for about 3 years, I guess now, including my summer internship. I work in the Kotlin language team and mostly develop libraries for Kotlin language.
So how did you end up with doing Lincheck if you are doing Kotlin labs?
And sometimes, and I'm also a member of the concurrent lab in the JetBrains research, and there I work sometimes on Lincheck.
Sometimes. What do you mean sometimes? How many people work on this project?
I guess Nikita Kovar is definitely working on Lincheck, and he has several interns now, and me. I'm just. I sometimes give some advices to the interns and sometimes work as a 20% engineer.
You devote 20% of your time to the Lincheck.
Yeah.
Okay, that's quite interesting. Dmitry, have you already forgot everything about Lincheck, or do you want to tune with Maria and understand new features of Lincheck?
I mostly forgot new features because I actually participate on the early stage, but when it's moved to JetBrains and Kotlin, I lose some tracks. So I will be
it would be interesting for you. This talk,
definitely.
Are you ready for that? Because as I've seen somewhere, as I've seen in my papers, that for this workshop you will need IntelliJ ID and the second monitor for active participation. Do everybody have second monitor for you? Dmitry, do you have a second monitor?
Yeah, and already opened my idea.
Oh, that's cool. That's cool. But unfortunately, Maria doesn't have the second monitor, but she will be the guide, so she will not participate herself in everything. So please listen to Maria and try to do everything she says. Okay, good luck, guys. I hope this will be an interesting workshop, and good luck to Maria, because this will be probably tough exam. Good luck.
Okay.
Thank you.
Thank you.
Okay, guys, so let's start our workshop. As Vitaly has already said, today we are talking about Lincheck, a framework for testing concurrency on the JVM. If you participate in the Hydra conference, I hope that you have written a concurrent algorithm at least once in your life. So I think it will be useful for you. At first, let's check the setup for our workshop. You will need the installed IntelliJ IDE. Of course, you can use any IDE you like. It would be more convenient for you to follow the guide if you have IntelliJ IDE. I've sent the link to the project with tasks for the workshop to our Telegram chat. That is called workshop on Lincheck, and has a green label. I hope you please clone this project. So let's start. If you have ever written a concurrent algorithm, you know that it's quite difficult. It's quite difficult to create a correct concurrent program. But testing concurrency is even more challenging than writing it. So we suggest you a solution for this problem here, and I'm introducing to you our instrument that is called Lincheck, that stands for linearizability checker. Linearizability as the default correctness contract. Of course, Lincheck supports not only this correctness contract, but also others. I'll tell you about this a little bit later. And here is the quick recap of what Lincheck does under the hood. On the high level, it just generates a random scenario, random concurrent execution scenario of your program, and then executes it either in the stress or the model checking mode, and verifies the results according to the correctness contract that you've provided. As I've already said, that is linearizability by default. On this workshop, we will cover both testing strategies, like stress and model checking, and configuration for scenarios that you can that Lincheck will generate, and the verification process. So to get familiar with the instrument, we are going to start with a simple example of a counter. We will have a volatile field value, volatile integer field value, and one function on the counter that actually performs an addition of some integer delta to the value field and returns the new value. Though the integer value field is volatile, this counter still seems to be incorrect because addition is obviously not atomic. So let's write a simple test for the counter using Lincheck. We create a class called counterTest. Guys, a quick note that I'll show you examples in Kotlin as was written in the description of my talk on the site. But you can also write these tests on any JVM language you like.
Maria, there is a question, unfortunately. Sorry to interrupt you. Which IDEA version do you need to install? Anyone, any version like 2019 or 2020, no matter. Also, is community version is enough?
Yes.
Okay, good.
So let's move on with our simple test. So we are writing a counter test. All you need to do is just set the initial state of the counter using the constructor, and then declare all operations defined on the counter. Here we have one, just addition. So we add it to the test, mark it with a special annotation operation, and just delegate this function to the function on the counter. And then we just write a GUnit test. We calling just some function check that will do all the work for us automatically. And we need to just run this test. So if you have already cloned the project, you can do this. You can see this test and run it by yourself right now. Please open the project and check out to the branch 1.1 counter. I'll open it with you. This will be just. Here we'll just see the test that run it, and along the way check that everything is ready to follow other examples. So if you check out to the branch 1.1 counter, there you can see in the main folder you can see the counter class with the implementation that you've seen on the slides, just an integer volatile value and the function that performs addition of some integer delta. And in the test folder, you can see the counter test. How can I know that everything is okay? Vitaly, please help me. Are there any problems in the chat? And Is anyone following my guideway?
Yeah, there is a question that the person couldn't get the head.
What?
Yeah, because gcenter is closed for now.
What does it mean?
Gcenter was shut down a month ago, I probably officially.
What's the problem? I don't quite get it. What's the problem with gcenter? I don't need gcenter.
Your current configuration probably, or user's configuration is referencing Kotlin compiler through the gcenter URL, which isn't available anymore.
Okay.
I think it's maybe some local problem with
I guess
user environment.
I think yes, because the Gradle project that I've provided does not require any gcenter dependencies. Yeah, in the repositories you can see only Maven Central dependency, and that's all.
At the same time, Gonzalo told that it worked for him, so wow. I don't know what exactly the issue. Probably the old version of IDE is the issue.
I don't know that the version of the IDE somehow makes any,
okay. Further decided to try to handle it by on its own.
Okay. So okay,
let's continue.
That's not a problem if someone just misses something. In this example, we just go into. I will discuss all the results that we get from this test on the slides, on the further slides. So that's not a problem, and I will repeat all these test classes later. So if we run the test that we've seen on the slides. Just pressing the green triangle, just running the usual JUnit test, and see the output. You see the following. Just at the beginning, you see a scaring warning. For now, don't pay attention to it. I will explain to you what it means a little bit later. And then in the output, we see invalid execution results Lincheck got. Of course, our counter that we've tested failed, and it's not a surprise because addition was not atomic. And we got these results that two parallel additions were performed, and one update was lost. So that's really a problem. But here we ran this test in the stress mode, as you can see here, and the stress mode just provides you incorrect results. If we want to know what exact thread interleaving led to this incorrect execution, we need to switch the mode of the test to model checking mode. That's done very simple. You just need to switch the stress options class that you call check function on to model checking options, and then the trace will be run in the model checking mode, and we'll see the results now. Okay, I'll change it. I'll change the mode of the test to. And we run the test again. So again, all you need to do is just switch the mode of the test. The test fails again. That's expected. And here is what we see. I think it would be more convenient to analyze this output on the slides. There's exactly the same one. So when you ran the counter test in model checking mode, you saw the following output: two parallel additions that return the same result. So we performed addition of 1 and the new value of the counter was 1, returned was 1. And in parallel, we performed the second addition of 2, and we get 2. That's not an expected result, and here is what happened. At first, the second thread started its execution. It started to execute the add invocation and read the old value of the counter. It was 0. And then the execution switched to the first thread. The first thread completed the addition of 1 to the end, and then the execution was switched back to the first thread, back to the second thread. I'm sorry. The second thread continued addition with the writing of 2 to the old value read to the old read value of the counter, and the resulting value of the counter is 2. So that's actually not correct. And what we've expected was what results we have expected. We were expecting the results of the first addition could return 1 and the second could return 3, or if at first the addition from the second thread was performed, then it would return 2 and the first thread would return 3. So I guess now we can we said that the counter was incorrect, and I guess we should now define what is correctness for us. What correct behavior do we expect from our concurrent algorithms? So if we talk about sequential algorithms at first, then we consider them to be correct if they satisfy the sequential specification on operations. Consider the example of stack. For stack, the sequential specification on its operations push and pop is last in, first out. So we push some element and the last element is popped. If the stack satisfies this sequential specification, then we consider it to be correct. If we talk about concurrent algorithms, that's a little bit harder because there are many operations executed concurrently, and it seems that we cannot talk about any sequential specification. And so the default correctness property for concurrent algorithms is linearizability. We will now intuitively, linearizability can be thought of as atomicity of operations. So as if we return back to our counter, then we would say that it was linearizable if additions were performed atomically, so that we could somehow provide the equivalent sequential execution of additions. Let's talk about linearizability a little bit more formal. We say that execution is linearizable if there exists an equivalent sequential execution that saves the happens before order on the operations. Let's see this easy example. So we have some register X, and we can write to it and read its value. If we say that write an operation happened before the reading, what we can say about this execution? Is it linearizable? If it would be linearizable, then we could find some way to order these operations so that we could to order these operations, saving the happens before order, so that we could get these results. We cannot do this because actually, if we want to read 0 from X register, we should first read from it and then write 1. On the contrary, this execution is linearizable because we can find the sequential execution that does not violate happens before order between operations, and still we get the expected results. If we let's carry on with counters and just watch at a little bit more complicated example, that is scalable counter. By scalable, I mean that it does not increment the single value, but it has an underlying array. And increments random cells from this array. So if there are multiple threads incrementing the counter, there would be no contention between them. And the sum of this scalable counter is implemented as just a linear walk along the array and adding of all the values in this array. Actually, this is a high-level idea of lone adder. Lone adder is, if you're not familiar with this class, it's a scalable lone counter from Java concurrent package. It's preferable to use lone adder to atomic lone when multiple threads are updating a common sum, and lone adder increases array size under high contention, so it provides a greater throughput when multiple threads access it. And now I suggest you to check what correctness guarantees are provided by lone adder. To do this, please check out. I hope that all of you have managed all your troubles with the project. Write to the chat if that's not so.
Yeah, if you have any problems, please write to the chat right now, because otherwise you will be lost somewhere.
Yeah. So now, because now we are going to, you are going to write something by yourself. So if everything is okay, please check out to the 1.2 lone adder branch. I'll go to the IDE with you. There you can find lone adder. There you go. No. Okay. I'll go to this branch too. And so here you can find in the test package, you can find lone adder test. That's just a sample of test. It does nothing now. You should complete these to-do blocks and then run the test and see the results. So that it would be easier for you to write the test. I left Kotlin test as a guide for you as a guide for you to write the test with all annotations and stuff. So now we can. I think we can have some time. We can give some time to the attendees to complete this test. Yes, Dmitry, we can talk to the expert, I guess, for now.
Okay. Well, I think for the moment something surprising happened in previous tests because we got operations with parameters, but they come from nowhere. And
for now, we don't have in lone adder test. We don't have operations with parameters. I just want people to write test for concurrent execution of increment, decrement, and sum. We are not generating any parameters.
I mentioned previous test when there were parameters.
Okay.
And we have some random values.
Yep. For now, let's take parameter generation for granted, and we'll talk about them in several minutes, guys. So let me do this. All we should do here is just delegate functions increment, decrement, and sum to the corresponding functions on the lone adder. Yep, and sum too. And then run the test. Let's say we run the model checking test. Model checking options and check. So we can run it now. Oh no. Okay. I failed to write this test because I have not marked operations with operation annotation, so Lincheck does not know what operations to use to generate concurrent scenario. And we run the test, and it should fail. Spoiler. Yes. Yes, and it fails. And let's see the output. Something went wrong. Something went wrong, and let's get back to the slides, and I'll explain to you what exactly is wrong with concurrent execution of increment, decrement, and sum on lone adder. Lincheck tells us that these concurrent execution of these operations is not linearizable. Here's what happened. If we consider this scenario that you saw in the output, in the first thread, we have two operations, increment and decrement, and in the second thread we perform sum. So why this execution is not linearizable? The only way to get negative sum in this case is just to perform at first decrement, then get the sum of the counter that will be -1, and then perform the increment. But this sequential execution violates the happens before order between increment and decrement. Happens before order there is obvious because they're in one thread, and this order is set by the program execution. Happens before order is violated, and the execution is incorrect. What is happening? What is happening inside the scalable counter? So we have the array. We have the array. Let's say that it's all zeros initially, and the second thread starts to perform the sum function and goes to the middle of the array. Still, the sum is still 0, and then it suspends. The first thread starts its execution. As we remember, the increment chooses the random index in the array and then increments the cell on this index. So it could choose the index behind the current position of the second thread and increment it. Then, while the second thread is still suspended, the first thread continues its execution and performs the decrement of another random cell that is above the current position of the second thread. The first thread completes its execution, and then when the second thread continues to walk along the array, adding all the values, it gets -1. So we see that lone adder does not guarantee linearizability for all operations, and concurrent execution of increment and decrement and sum is not linearizable. Though if we only use increment and sum, linearizability is guaranteed. Then lone adder would be linearizable. If you want me to explain you formally why that's true, yeah, you can ask me in the question section, I guess. So by now we got familiar a little bit with the instrument. Please write to the chat if you were able to write the test to lone adder and follow the output with me. and also if you had some problems, maybe we can resolve them now. Vitalia, are there any problems in the chat? And can I move forward with the presentation?
No, there are no questions. I don't know, like, do you know?
No questions yet.
Do you know how many people are watching so we can check the progress? Any idea?
I don't know, but
we have 9 members in the chat.
5 members?
9.
Okay. 9. That's a success. There were 7 of them at the beginning.
Okay, no, I don't see how many people are watching this, unfortunately. But I know that there is at least 3 persons who do this. But there is approximately 3 persons who do this. At least 3 persons.
Mm-hmm.
So and
okay, the guy that had problems with G-Center, has he resolved them? Okay. I guess they can write to the chat.
Yeah, so please write to the chat if there is something wrong, because I know that it's tricky to work with Lincheck. That's
okay, but still you have. I should say that after the workshop, I will push branches with solutions to all the tasks, so that you could follow them if you have troubles now.
Okay, I got 2 messages from the people, and they are all fine.
Okay.
So, like, you can move forward.
Cool. So now we got familiar with the instrument and got some high-level idea of how it works. Now let's dive into some details on the testing strategies. And at the end, we will start with stress testing. We've already run the test in stress mode. That was the first test on the counter. The high-level idea of what stress testing does under the hood is that it's quite straightforward. Lincheck, in the stress testing mode, Lincheck runs real threads, synchronizes them at the start, and then executes this scenario for each thread multiple times in hope to hit the incorrect execution. Here is, on this picture, you can see the scheme of how the stress execution could look for long adder test. This stress testing mode was the first testing mode supported in Lincheck, and it was inspired by the testing applied in GC-Stress. GC-Stress is the tool that was initially created for testing Java memory model, and you can use it to check bugs and on the low level. And you can go to the workshop that will be had by Alexei Shepelov on day 3, and he will tell you about GC-Stress in details. And we are moving forward to a more interesting testing mode that is called model checking. What's the problem with stress testing? As you have seen with on the test of the counter, stress testing just provides you incorrect results, and you can actually spend a lot of time then trying to find out how some incorrect execution found by Lincheck could happen in your program. And that's why we decided to solve this problem by adopting the idea of bounded model checking in Lincheck. Initially, this idea was inspired by the framework called Chess that is used for C#. The idea is that you have some execution scenario, and you try to provide a managed execution, setting switch points to the different places in the threads, setting switch points to the different places in the threads, and so and choose different interleavens. We supported model checking for sequential consistency memory model, as in our experience, most of the bugs can be reproduced under the sequential consistency memory model. And by the way, model checking for weak memory models is rather tricky to implement. The high-level idea is that we examine many different interleavens within a bounded number of context switches. As I've already said, the main motivation to provide model checking was to get a trace that reproduces the incorrect execution. And now let's see very fast how model checking works under the hood. I've placed the code of the counter that we've seen at the very beginning of the workshop, and now we are going to see how model checking test works there. So to analyze different interleavens, we build an interleaven tree. We start an execution. We start at first we have one context switch available. So we start the execution, and our concurrent execution consists of 2 threads. At first, we should choose what thread starts the execution. Let it be the second thread, and then we should choose at what switch point we should switch the execution to another thread. The switch point. The interesting points in the code that could be switch points are reads and writes of the shared memory, or some synchronizations like acquisition and release of the lock, notify and wait, park and park. So for our counter, we choose the first read as the switch point. So after reading the value of the counter, we make a switch to the first thread, and then when we are there, we should just complete the execution. This was how we found the first interleaven. For every to have an idea how we can build the next interleaven, we provide percentage of exploration of all interleavens for every subtree, and we use these ratios for the weighted random to choose where in the tree we should go for the next interleaven. So in this case, there is a greater probability that we will look for the next interleaven starting from thread 1. As now we've seen how stress and model checking work under the hood, and here on the slide you can see where you should use stress testing and model checking. Stress testing is good stress testing does not provide a trace to reproduce the error. It's good to find low level bugs, like, for example, missed volatile modifier. And we also use it to find some rare bugs that require a lot of context switches, and just they cannot be found by model checking due to its boundaries. And model checking is great for sequential memory algorithms. It provides better coverage, and the main advantage of model checking is that it produces a trace to get the exact interleaven that led us to the error. Now we go to the more practical part, and we are going to talk about configurations of scenario that you can set manually. Till this moment, we just invoked check on the stress options and have not set any options. For example, you can set the following configurations of the scenario. You can set the configuration that is called actors before. It creates the initial part. It generates the initial part. You need initial part in your concurrent scenario to set the initial state of a data structure. Then you can configure the parallel part and set the option that is called actors after to generate a post part. Post part is needed to check that everything is okay with your data structure. It's not broken after the parallel part execution. Also, you can find these options, you may set more invocations per iteration if the bug cannot be found with less invocations. That means that Lincheck will run the generated scenario this number of times in their selected mode. And another very useful feature, I guess, is setting custom scenarios. It's needed when you know what scenario may violate some bug, and you can set exactly this scenario and run it a lot of times. To see these configurations in action, you can check out 2.1 low-level branch. There is a test. That reviews the bug with missed volatile modifier. It's called weak memory test. You can run it and see how it fails. Vitaly, can you please tell me, should we go faster? I guess we should, because we have 28 minutes left.
No, we have 28 minutes left for the first part.
Yes, we have 28 minutes for the first part, and I guess we still need to...
How much time do you need for the first part in this?
I guess that's okay. That's okay. We're going in the first part. We are going to have 2 more tasks. So if you...
Okay, let's try to continue then.
Let's try to continue. Yes.
If you want to speed up, please speed up. If somebody is not fine, please tell us in the chat whether it is too fast for you, and we will try to make it a little bit slower.
Okay. The test from this branch. The test from low-level branch is just to see how configuration may be set and how custom scenarios work. You should just run this test and do not write anything there. As Dmitry has noted at the beginning, till this moment, we took parameter generation for granted, and sometimes it's very useful to set some range of arguments passed to the function, for example, to increase the contention. If we see the example of hash map on the slide, hash map with defined put and put method, we can set the configuration for the argument this way. If we have another method on the map, like get, that also gets the key parameter, we can share the configuration of the key, just defining this param annotation on top of your class. There you can name this configuration, pass some generator, and set the string configuration that defines the range of the values you want to get. So, and here is a quick task. to set this parameter generation annotation, and it's located in the next branch 3.1 lone adder. Please check out and find lone adder test there. Lone adder again, so that we now go into set parameter generation annotation to the add method, and see whether these methods provide linearizable execution. In the last example with lone adder, we got an error with concurrent execution of decrement and sum. So let's check. Will add be okay if we set the positive range of arguments, if we will add only positive values to the lone adder. So let's write it. Dmitry, how are you? Talk to me, please.
Well, I was interested that some operations may produce errors only when the parameters somehow correlated. For example, if we access the same bucket in the map, so does Lincheck provide some hint to produce the same values, some random, but the same values for different operations in the scenario, or somehow other tool?
So you mean if we can pass the same values, not just the same configuration? Like what? I don't quite get you. So we can pass. As I've showed on the slide, we can just share the configuration, and the parameters will be generated from the same range for all operations.
Okay, so we should choose the narrow range to increase probability of clashing
yes.
parameter value
yeah.
on the operations. Okay.
Yeah, and we will see. So here is
Dmitry, do you keep up with the pace that Maria has started?
Sure. It's okay for me, but I generally know about the instrument. Maybe it would be harder to some novice users.
So what? Oh no! Oh no! Oh no! I have some trouble. Yes, because I switched the branch, and so guys, is everything fine? So we, as I've shown you on the slide, we can write the parameter configuration just like this. We should generate lone parameters, so we pass lone generator, and we set the configuration from 1 to 5 that like it was written in the to-do block. We have another example. We have another example of this parameter generation. You can just have a look at it. We are using Lincheck. We have Lincheck tests integrated in GC-Tools library, and eventually we have found a bug in the non-blocking hash map, and that is a great example for parameter generation. It was found in the GC-Tools version 3.1 and was fixed later, I guess in the version 3.3. But you can see this non-blocking hash map test. There was a bug in concurrent execution of get and put operations. And that is the example of a shared parameter generation annotation. You can run both stress test and model checking test and review the bug. And I guess we should move further. Please write to the chat if you have any questions. we will, while you're looking at the tests, I should say that we can also pass not only not only value generators that are supported in Lincheck out of the box, but also write your custom parameter generator. That's quite simple. You should just implement the parameter generator interface and override generate function. The only restriction is that generated values should be serializable. So let's move further to other configurations. Sometimes your data structure may provide some constraints. Some constraints according to the contract. For example, you have a single consumer and multiple producer queue. And if we just write the test the way we've done till now, we can get, Lincheck can generate you the following scenario with several consuming operations, with consuming operations performed from different threads. And of course, that would be considered an incorrect scenario. That's true, because our queue, according to the contract, did not support several consumers, multiple consumers. And we need a way to tell Lincheck that we need one consumer only. For that, we can just create a group of operation that should not be executed in parallel. You just on the top level of your class, you create this group, you name it, and say that they should not be executed in parallel, and then just pass this group name to all operations that should be performed from one thread. And we have an example for this too. So please check out the 4.1 constraints branch, and please perform the test. I guess I was okay. I guess I speed up a little bit, but I still have enough time. So we should do this. We should do this test. We have a queue here, queue from GC tools, multiple consumer and multiple producer and single consumer queue. According to the contract, all consuming operations should be performed from one thread. So you need to create this group of non-parallel operations and then run the test. If you run the test now, it will fail, of course, because Lincheck will generate you a scenario with consuming operations from different threads. I think that we can have some time here for attendees to perform this test, because we still have 15 minutes till the end of the slot, and I thought that this would be the end of the first part. Dmitry, please talk to me again.
Okay.
Do you have any notes?
I think it's fine. I have some questions for maybe going deeper in some details. Actually, I was planning to ask about stress mode, and what if we have some much longer operation on some side and much shorter operations on the other thread, when we are maybe never interleaving in the interesting way.
Can
we handle it somehow?
In the previous versions of Lincheck, we have inserted the busy wait cycles between operations so that we could get more different interleavings. So just what you say. When we have a long operation and a short one, we could have we could set some random busy wait cycle before or after that short operation, so that we could get different interleavings.
You said in the
In the
previous
versions, because now we do not do this way. Because eventually we found out that bugs. We find bugs in a better way without these busy wait cycles.
Oh, that's interesting.
Yeah.
Okay.
So how are is anyone following the tasks? I wonder.
Let's check out how many people are listening. Please write plus in the chat if you are still there.
If you are still there, and if you have managed to write the test.
Probably you have some questions on how something works. Probably from the theoretical side, I think.
For the theoretical, yeah, because I sped up a little when I was telling you about how model checking works under the hood, and I guess you have not understood anything because it was quite messy, I think.
So there is at least 6 persons for trying.
Yeah, we have more active listeners than before. So
More active there.
The popularity is increasing.
So guys, probably you have some questions until this moment. Probably some of their questions whether you're interested from the theoretical side, because Maria you've implemented model checking, right?
No, not me, but an intern. But I know some of internals of model checking. I guess now we can answer the questions if there are any, because the next question is quite global. It's about checking for progress guarantees, and we are not going to. I think we cannot finish it in 10 minutes, but we can try. We can move to further section if there are no questions. If there are no questions on scenario configuration and all the previous stuff, what do you think?
We still don't have questions in the chat, so maybe we are.
Okay, it's not obvious for Vyacheslav to read the results.
Yeah.
How you should read the results. Probably you can show us.
Okay. Let's read the results on what test? What test?
At some interesting test, probably.
At some interesting test. Okay, we should choose some interesting test. Let's move to the branch 3.2 GC Tools. 3.2 GC Tools, where we've written a test for the non-blocking hash map from the GC Tools library, and that should fail. So if we run, for example, model checking test here in the class non-blocking hash map test, it fails. It fails with the following results. It's very messy because we ran model checking test, and we get the whole trace of how this interleaving was produced. So here we see the invalid execution results, and followed by the exact scenario that reviewed the bug. So the incorrect execution occurred when there were 2 put operations performed in parallel. Here we see that there was performed an operation put by the key 5, and we put -8 there. Then we put 4 by the same key and got -8 as the previous value. And then in the post part, we checked the state of our data structure. We should get here 4, I guess, like the result of the second of put operation from the second thread. But we get -8, and that's not correct. I think we've just lost the update of the put from the second thread. And here you can see the trace, the whole trace that led to these incorrect results. I guess that's for model checking. I guess we can see it's a very complicated example, I guess, to see how model checking produces an output. We can again see the example of our counter and run the model checking test on the counter. Here we see again the output that starts from invalid execution results, 2 additions performed in parallel, and one update was lost. And then we see the trace that we've discussed on the slides that produced there is an exact interleaving that produced the incorrect results. So we have here read. We've discussed it. I don't know.
Okay, so
we have read and write operations and some atomic, I suppose.
Yes. That was a failure of non-atomic counter that we've discussed. So the second thread. We see here that the second thread started reading the value of the counter, read the old value, and switched the execution to the first thread. The first thread then completed addition to the end, and then the execution switched back to the second thread. Yeah, and so we've updated the old value of the counter and returned it. So here we've lost the update from the first thread.
So Vyacheslav, did it help you?
Okay, and we have a question from Yaroslav.
We also have a question from Michael. Michael is
first.
But
it's more complicated. I think that Yaroslav is more basic and more important for the moment because Yaroslav don't understand how the correctness of the result is validated at all. So
how correct? Okay, we'll talk about it at the end of the workshop in the section called verification, and we'll see that when we get results, we then Lincheck then has the stage of verification where we try to find that sequential execution that could provide the results that we've got according to the definition of linearizability, and I'll show you there how we are doing that.
Okay, so simply talking, it's just enumerates sequential scenarios until it finds something with the same result.
Yes. That's true.
Since we have time, probably you can ask on Michael's question.
Okay.
Yeah, this is a tricky question. How many scenarios do you simulate using stress test?
You can set the number of scenarios. You can set the number of scenarios that are generated via stress test in the options that I've shown on this slide. The option is called iterations. The iteration option sets the number of scenarios generated, and by default, I guess we generate about 10,000 scenarios or 1,000.
Actually, I think that Michael asked about model checking and
for model checking,
the explosion problem.
And for model checking, the options are the same. So we can set the number of scenarios generated for model checking the same way.
And we have some internal strategy to get some fair coverage of interleaving tree.
Yes. I guess I can ask the questions about the internal strategy of model checking again when we have time for questions. Because maybe.
So Yaroslav has asked a further question. So it gets a huge number of given operation permutations, and in case if there is no permutation, which is similar to what we got at runtime, the execution fails?
I don't quite get the question. What say? If you have, okay, I'll read it. Okay, that's the question from
Yaroslav, yeah.
From Yaroslav, I don't know. Yeah. In case if there's no permutation which is similar to what got the runtime execution fails, yes, okay.
Yeah, I think exactly. Okay. This is the verification process. That
the verification. Yes. If we cannot find the permutation of operations in this scenario, that sequential permutation of operations in this scenario that leads to the result that we got during the execution, then the test fails. That means that the execution is non-linearizable, and yes, we didn't find the sequential execution with the same results.
Okay, so do we have any more questions? I think not, right? So we have like some minutes to do. So probably you can.
I guess I can now push the branches with solutions for those tasks that I've given.
Okay, that would be interesting. But can you probably give us the brief description of what you are going to show in the next session?
In the next session, we are going to talk about progress guarantees that are as important as correctness guarantee, and we'll say that Lincheck can detect if your algorithm is blocking or not. We will also talk about modular testing. It solves the problem when your data structure uses some other linearizable data structure as a building block, and you may have trouble to test it. You may have trouble to test such a complex algorithm because of many interleavings to analyze. So we have some solution for how we can decrease the number of all possible interleavings. And at last, we will talk about verification, how we try to find that sequential execution under the hood. So I guess that would be the workflow.
So the next session will be more intensive and more interesting, I guess.
I guess yes, because here we've just talked about different configurations and just the high-level idea of how testing strategies work under the hood. So now I'm going to push.
Is there anything that should be prepared for the next session?
For the next session, maybe you can read.
Probably we can set up something right now, or like.
There won't be any special setup because we would just follow the tasks in the way we did in this half of the workshop. Maybe some theoretical. I'll tell some theoretical moments by myself too. I guess everything will be fine.
So we have 1 minute left. So let me thank Maria for their first part of the workshop. I hope she will be ready for the next part. I guess she's not tired at all.
Yeah. Everything is okay. Guys, please write to the chat if you have any notes or suggestions.
And we still have time before the before the break.